Okay, so this is a 6.5 notes over rhombi and squares. All right, so we're going to talk about the definition of each and then look at their properties. So a rhombus is a parallelogram, so it's still considered a parallelogram with all four sides congruent. Okay, so this is something new. All right, in a rhombus, all four sides are congruent, kind of similar to a square, right? However, the difference here are obviously going to be the angles. Okay, so it is a parallelogram, meaning all the same properties of parallelograms hold true. We also have four congruent sides. Okay, opposite sides are parallel, opposite sides are congruent, consecutive angles are supplementary, diagonals bisect each other. Okay, this is new. Diagonals are perpendicular, meaning that they form right angles where the diagonals intersect. So there are four right triangles within a rhombus. And each diagonal is going to bisect a pair of opposite angles. Okay, so if I were to look at this diagonal right here, this diagonal is bisecting this angle and this angle. Remember, opposite angles are congruent. Okay, and now these opposite angles are getting bisected. All right, and then same thing for this diagonal. It is bisecting this opposite angle. Okay, it does not mean that these angles are congruent to these angles. It just means that now these opposite congruent angles are also getting split in half. Okay, so a square, all right, a square is a parallelogram with all four sides and angles congruent. So now we have kind of a mixture, right? A square is actually the combination of a rhombus and a rectangle. A rhombus has all four sides congruent, and a rectangle has all four angles congruent. Okay, each interior angle measures 90 degrees, right? There are four right angles in a square, and all four sides are congruent, as you can tell that they've marked them. If a parallelogram is both a rectangle and a rhombus, then it is a square. Okay, so rectangle and rhombus, rectangle plus rhombus equals a square. All right. So we know the properties of each a rectangle and rhombus now. All right, all four sides are congruent. All four angles are right angles. Opposite sides are parallel, like a parallelogram. Opposite angles are congruent, right? They're right. Consecutive angles are supplementary. Diagonals bisect each other. Diagonals are congruent. That was from the rectangle, right? Here's the rhombus property. Here's a rectangle property. This is also a rectangle property. Diagonals are perpendicular, and each diagonal bisects a pair of opposite angles. So every property about a rectangle and a rhombus combined would make a square. Okay, and squares are typically easier, right? Because everything is going to be equal. Okay, 45, 45, 45, 45, 45, 45, 45, 45, right? All four sides are equal. Diagonals are equal. Here are four right angles right here. Okay, so kind of like an equilateral triangle, this is a regular quadrilateral, right? The square. All angles and sides are congruent. So here is a Venn diagram of parallelograms, rhombi, rectangles, and squares. If we're looking at parallelograms as a whole, right? This is kind of my Venn diagram of parallelograms. We had rectangles after parallelograms. We talked about the rhombus, and then when those two combine, we get a square. Okay? So, on the next page, we'll solve some problems. An example 1 here is rhombus TUVW. So if I have a rhombus, I know that all four sides are congruent. They told us that side TU is 15, making UV 15, WV 15, and TW 15. If it's a rhombus, I know that my diagonals are perpendicular, so there's 4 right angles. And I know that opposite angles are being bisected. Okay, opposite angles are also congruent. So here's an angle, right? These opposite angles are bisected, so 35, 35, making over here 35, 35, right? Opposite angles are congruent and they're getting bisected. Okay, so let's kind of go through. It says that diagonal TV is 24, making TO 12 and OV 12, right? Those two congruent halves. The measure of TVW, which is over here, is 35, so we figured that out. Okay, 35, 35, 35, 35. We want to go through and find these angles and these side measures. Okay, so the measure of angle 1. All right, angle 1 is down here, right? They didn't give us that angle, but I do have angle V, right, 35 and 35, which equals 70 degrees, okay, as a whole, right, this entire angle. Remember, this is still a parallelogram. Consecutive angles are supplementary, right? These are opposite angles, T and V. Consecutive would be W and V or U and V. Okay, consecutive angles are supplementary. So I can take 180 and subtract angle V, which is 70, right, as a total, and I get 110. That means the entire angle W is 110, and if it's getting bisected, that means it's getting cut in half, where each part is 55 degrees. Okay, so angle 1 is 55. Which means angle 3 up here, right? This is the same congruent angle and it's also bisected, so 55 as well for angle 3. Angle 2, well, that was opposite of one of the angles that we had, right? So angle 2 by itself is just this part, 35. Angle 4 is one of the right angles that are diagonals, so that's 90. TO was from point T to the midpoint. Okay, remember diagonals bisect, so they gave us TV. The entire diagonal was 24, so half of it is 12. And then UW. Okay, UW is this entire diagonal right here. We don't know anything about this diagonal, right? I wasn't given OW, I wasn't given OU, okay? But remember in a rhombus, I have 4 right triangles. They gave me this side 15 of my rhombus, and I know this piece right here 12. I could figure out U to O by doing Pythagorean theorem, right? It's a right triangle. If I'm missing one side of any right triangle, I can use Pythagorean theorem. Here's my 90-degree angle, making this 15 the hypotenuse. So I'm going to solve for UO right here using Pythagorean theorem. I'll call that x for right now. So x squared plus 12 squared is equal to 15 squared. Remember, the side that's opposite of the 90-degree angle is going to be your hypotenuse, which is always going to be C. So x squared plus 144 is equal to 225. Then I want to subtract over 144, so 225 minus 144, I get 81. Then if I take the square root of 81, that gives me 9. Remember, that was just this piece right here, but diagonals bisect, making this piece OW also 9. So 9 plus 9, UW is equal to 18. Okay, so that was our rhombus. Now let's do an example of a square, and then after this example I'm going to stop this part 1 video and do the coordinate geometry and part 2. Okay, so quadrilateral ABCD is a square, right? They stated it's a square, so all of our properties of a square are true, right? All these properties that we learned. Meaning I have 4 congruent sides. Okay, it says if OC, which is part of my diagonal, is 5, Remember, everything in a square is equal. This is also a rectangle. So my diagonals are congruent. So 5 is OC, which means OA is 5, DO is 5, and OB is 5. All the diagonals are congruent. The diagonals are perpendicular, so again I have 4 right triangles. All of my sides are congruent. All of my angles are 90, right? And they're also getting bisected. So every 90-degree angle is going to be 45, 45, 45, 45, 45, 45, 45, 45. So angles 2 and 3 are both 45 degrees. Angle 1 is one of our right angles at the diagonals, so there's 90. It's asking for OB. Well, OB was 1/2 of one of my diagonals, which diagonals are congruent in a square, so that's 5. Okay, BC. BC is one of the sides. All right, I wasn't given a side measure, but again, I have right triangles within my square, and I have both sides of the 2 legs, right? 5 and 5. I can do Pythagorean theorem. Here is the side opposite of the 90-degree angle, which is always going to be C, right? ABC. Okay, so 5 squared plus 5 squared is equal to C squared. That's going to be 25 plus 25, meaning C squared is equal to 50. I just want C, right? I've got to take the square root. So for now, you can leave this as the square root of 50, or you can provide a decimal. When we get to chapter 8, we will be simplifying radicals, but the square root of 50 as a decimal is approximately 7.1. Okay, and then BD is one of our entire diagonals, right? So 5 plus 5 gets me 10. Okay, so I'm going to stop this video right here and do the last example in part 2, just because it's coordinate geometry and it requires a few more steps. So go ahead and pause this and go to video number 2.